I've known Jed, like I said, for 8 or 9 years now. Visited his facility many times. Jed has been in the framing business for over 40 years, Bark Frameworks. He is widely and highly regarded among high-end collectors. He does a lot of framing for museums. If you've ever been to his facility, you'll see that he has carvers there and he makes unique, one-of-a-kind moldings. Very interesting process to watch. Jed also wrote the book on, or the white paper on, glazing about 20 years ago. And it's a white paper that we have referred to as we've developed our products, and I've seen it referenced in a number of other documents on glazing. So it's my pleasure to present Jed Bark.
Thank you, Patty. Thanks also to New York Historical Society for this wonderful room to meet in, and to all the TrueView staff here today. I think I'm just going to press a button here. Works. This is pretty low tech, so I think this will be easy. I wanted to say that as I start, that we can answer questions, can entertain questions at the end, but if you have something urgent to say in the midst, it's okay to interrupt. I've asked Brian Olson, the chief engineer from TrueView, to gently correct me if I say anything that he takes issue with on the spot. So now we'll get started. What Patty said is true, that in 1991 I wrote this paper that I sort of spread around informally, and I don't know if you all can read it from back there. Can you read it how far back can you read it? No, not too far back. Okay, this is a little bit like Van's introduction, in that what I wrote almost 20 years ago was the ideal glazing material would transmit without distortion all the light in the visible spectrum, reflecting none, and would be opaque to ultraviolet radiation. It would resist impact and abrasion, carry no static charge, and neither expand nor contract with changes in temperature and humidity. Available in any size, this material would also be lightweight, rigid, inexpensive, and show no effects of aging. Next paragraph. Sad to say, no miraculous glazing material exhibits all these qualities. At best, our options today satisfy only 3 or 4 of the dozen requirements listed above. Our task then is to sort out the best choice for each circumstance. And that certainly was true 18 years ago. It's no longer true now. Many of those qualities are available, most especially in the new Optium product that's about to be distributed, which is, we have some here. You can see it afterward. Back a long time ago, 30 years ago or so, our glazing options were quite limited. Matte board had already made a progression that in many respects glazing materials have since, say, the early 70s. In those days, for acrylic glazing, we had UV shielded cell cast. It was very expensive. This would be mostly from Roman Haas, UF3, UF4. There was extruded material, but initially it wasn't available in UV shielding at all. In the 70s, we started seeing first, Cyro was the first, to my knowledge. They introduced OP3, which was an extruded. They couldn't use the word extruded because extruded was such a bad word. It was called continuously manufactured. But it was pretty high quality and similar to the quality today, which I feel in terms of our use as framers is very close visually to cell cast. we have a hard time if we lay two pieces side by side to determine which is cell cast and which is extruded. So in those early days, there was very little choice in acrylic, and I'm going to show you now two pictures of glass. This is old window glass, not picture glass, but I don't know if you can see them from the back, but those are cat eyes. Glass was also extruded. Anything pushed through a die is considered extruded, and that's how glass was made and then ground and polished. And any little air bubbles in the glass would be distended in the process of extruding and become these telltale cat eyes, which you always had to cut around. And these are two huge cat eyes that you can see. These two pieces, which are from some old school windows that I had in my barn at home. In 1957, Pilkington Glass in England developed, or in the late 50s, and they went into production in 57, float glass. And I remember when it showed up in the early 70s, it was really a great breakthrough. Float glass, as you may well know, is floated on molten tin. It's not extruded at all. Cat eyes disappeared forever. And many of the other defects, so-called music lines, extrusion lines, and other defects were a thing of the past. So overnight for us, it was also less expensive, much easier to make. So overnight, we had this great new glass product. And pretty soon, there were other developments. The Denton, for example, was producing Den glass in the 70s, a coated anti-reflective glass. It was a dipping process that they had licensed, I believe, from Schott, and then Schott, after 17 years, entered the U.S. market as well. There were many other kinds of glass that showed up in the 70s and 80s. Among water white glasses alone, glasses with very little iron in them, there was OptiWhite, Starfire, Diamant, Crystal Clear, OptiClear, and others, many of which have come and gone. Some of the companies making glass in the past decade or two have come and gone, or at least distributing glass. Sandell, I think Zuel's gone also, and as of 2006, and Den glass has no longer been made. So this has been an exceedingly volatile marketplace for glazing materials. And I must say that our hosts tonight also have one thing I would say is that they have stayed the course. They've absolutely stayed with the process. On the other hand, they also introduced things and then withdrew them, new products, took them out, come and gone. We'd have something for a while and then couldn't get it anymore, which is very frustrating. But the degree to which TrueView has stuck with this process on acrylic is very impressive, and ultimately I think is going to be great for those of us who frame works of art. I wanted just to go back. I've got just a list here of all these qualities that we're looking for, and we'll talk about them. I'm not going to repeat them since I read it, but we'll talk about them as I go along, most of them, and see what's happened with these questions of, for example, expansion and contraction and reflection and UV blocking and so forth. Before we had the experience of Denton showing up with their product, we had so-called non-glare glass. I think we all remember that, the etched glass, which was not useful for any of us. Denton's product appeared. Not long afterward, I had a series of meetings with a physicist, an English physicist who was a consultant to TrueView, a guy who'd actually worked with glazing, acrylics, and glass in England as far back, I think, as World War II, a fascinating guy. And they were developing a non-reflective surface and were very interested in talking to people like us about what we sought, because there was always going to be some degree of reflection, a percentage or two at 90 degrees. And what, green, blue, what was better, what color, because it was inevitable, was better than another. So we have this long history talking to people at TrueView about their material.